Hello, and welcome to What on Earth, the podcast in the Environmental Investigation Agency, or EIA. For decades, our wildlife campaigners have worked to secure a future for wild tigers in the face of existential threats, which range from poachers and illegal trade to China's industrial-scale tiger farms. EIA is also active behind the scenes, sharing intelligence with enforcement authorities around the world and seeking innovative new methods to help that enforcement become more effective. We're currently in the middle of one such project, which is to create a database of tiger stripe patterns to help identify individual animals both in the wild and in illegal trade. We're carrying this out in partnership with, and the financial help of, the UK's prestigious Turing Institute. I'm Paul Newman, EIA's Senior Press and Communications Officer, and today I'm delighted to be joined by Shaun Buckley, a data scientist at the Turing Institute, to talk about the project. Shaun, welcome and many thanks for your time.
Hi Paul, thanks for having me.
To bring our listeners up to speed, get us started, would you tell us a bit about the Alan Turing Institute itself, its background and what it does?
Yeah, so the Alan Turing Institute, I believe it was established about 5 years ago. It was established to address data science and the importance of data nowadays in the modern world. It was also recommended by the government to adopt artificial intelligence into their remit, as that was obviously becoming a much bigger thing. So they're essentially the institute in this country for data science and artificial intelligence in order to solve the biggest problems that the world are facing, so like sustainability, climate change, I believe cybersecurity as well, and things like that. Yeah. They also like to collaborate with other universities. I think they started originally with 5 of the top universities in the country, and now they are at least 8, maybe even more now. So they like to work with researchers and students from the universities and provide funding for various projects and the like.
And what exactly is the Tiger Stripe Pattern Database project?
So basically, this project is in an effort to collect the images of live tigers from camera traps and things like that, and also the images that are recovered by campaigners and investigators from the seizure of dead tiger skins and carcasses and things like that. And the idea of this project is to create an AI tool that basically can take these images, process them, and be able to output some sort of prediction or result, or a match, I should say, between known tigers. Or rather, if they don't know, then list it as a tiger that we haven't seen before, and then add it to the database.
I appreciate it's probably a bit reductive, but I mean, I understand that tiger stripe patterns are as individual as human fingerprints. So is effectively what you're doing coming up with a piece of software that can actually look at bajillions of individual fingerprints, or in this case, 4,000 tigers, and compare them and find out which one's which.
Yeah, in a sense, yeah. Obviously, it's a much harder task in the sense that we don't have access to millions and billions of fingerprints that I'm sure police forces and the like can get a hold of. But also it's because unlike things like fingerprints where it's directly read into a scanner, things like that, these are taken from camera trap images, are taken from photographers, professional and amateur, investigators just on things like a smartphone and things like that. So there's a great deal of scope with regard to the angle the image can be taken from, the distance, the light saturation, any potential obstacles in the way or distortions. So yeah, it's not reductive. It's very similar, but it's a much more difficult problem.
It's basically more complicated from your point of view than from mine, because you know what you're talking about. You've been with us for a few months now, and I understand the focus of the project at this stage is to develop this artificial intelligence tool that will help identify individual tiger stripe patterns. Before we get into that, could you give us a definition of what AI actually is in this context? I mean, it's a term that's bandied about quite a bit these days, with everything from people's concepts of AI creating artwork based on scans of extant artwork, right up to supercomputer hive minds controlling human reality. And I'm sure the reality of it is somewhere in between there, a long way away from the science fiction end of it. So, yeah, would you tell us a bit about what you think of as AI?
Yeah. So one thing I'd like to get out there is that AI isn't inherently scary. It's also not inherently powerful. AI gets its power, obviously, from very smart people doing smart things, designing good algorithms. But at its core, AI is powered by data. So if you have an awful lot of data, there's a good chance that you can create a tool, let's just say a tool, that can perform a task that you give it. And that's about as vague as you can get. Essentially, what you're looking to do is you're looking to provide the machine, the computer, with data, and then you say, I would like you to perform X and output Y. And at the end of a full run, it'll say, this is my prediction, this is my Y, what do you think? And almost every time you will initially say, this is rubbish, it's completely wrong. Okay, so that's how it begins. The way I like to put it as a metaphor is it's like teaching a baby to do something for the first time. So initially, you've got it has no concept of pretty much anything. So like a very, very young child, a young person, and they need reinforcement from the parent in order to establish patterns and understanding of various things. And a lot of the things they learn are through trial and error. And I'm not going to say that machine learning or AI is just trial and error, but a large part of it is it trying to understand the problem through doing. And in the context of our problem, this basically means taking images, and this is a very in-depth field at the moment, taking images of various different kinds of classes. We could just use a typical example. Imagine vehicles. So one class could be cars, another class could be trucks, another class could be boats. And you have a database of all these different kinds of images, all these different classes. And one of the most simple tasks you can get an AI to do is to classify all the images into whether it's a car or a boat or a truck or whatever. And with this project, we're looking to do a similar thing, except the classes are actually all the individual tigers. So you're looking to get a tool that can learn the very, very fine differences between one tiger's stripe pattern to another tiger's stripe pattern. And the concept of this is taking data, passing it to it, getting it to attempt to predict, and once it does badly, reinforce what it should be looking for. It will try again and again and again. And eventually, theoretically, it should be able to pick out the features that are important to distinguish between the tigers. That's
thank you for that.
Essentially what AI is in this context.
Excellent. And without wanting to vanish down a rabbit hole, while we're talking technical terminology, you mentioned algorithms. What exactly are algorithms in this context? Again, it's another one of those terms people throw around quite loosely. People talk about the Facebook algorithm reading way too much into what you are and what you're doing and what you're likely to do. But is it the same sort of thing? Is it a piece of predictive coding that?
Algorithm is more sort of a mathematical structure for processing data. So an algorithm will take certain input, it will perform certain mathematical operations on the input, and it will produce an output. And the idea tends to be that you use the same calculations every time you use the algorithm. So it will always use the same, maths and same algebra and things like that. It's not like it changes constantly. The thing that changes in an algorithm, or rather what changes in AI, is the weights. And weights basically correspond to how much you lean one way or the other, depending on what you've previously seen. So it's difficult to explain it, but basically, if you kept the weights or the understanding, let's just call it the understanding from the AI, the same, and you passed data through the algorithm, the result will be the same every single time.
Yeah.
For the most part. But an algorithm is essentially just a sequence of steps, mathematical steps for processing data, and AIs make use of algorithms in order to do all the different sort of scientific transformations on the data and understanding. And the AI itself is the thing that changes.
Okay, so effectively, it's like tools of inquiry that the AI uses to arrive at its determinations.
Yeah, exactly.
Okay. Thank you. And what for you have been the main challenges in developing such an AI tool for this particular project?
Yeah, well, for this particular project, I'd say it's probably the lack of data, or rather, I should say, strongly labeled data. We have quite a good amount of live tiger images. In terms of the tiger skins, we also have a fair amount of those. Far more live tiger images due to the camera traps and the photographers. But relatively speaking, we have a low proportion of tiger skins, and that's obviously the thing we're trying to recognize more than anything else. But there's also other issues. One of the reasons why the Turing Institute was so interested in this project is because there isn't a great deal of prior work in this field. There have been attempts in the past to do things similar to this, but never with dead tigers, never with animal skins themselves, more with walking about 3D, live tigers or even carcasses. But despite that doesn't mean that it's an impossible problem. It's just not really been attempted before. That makes it interesting, but it's also a challenge, obviously, because you have less to refer to. And finally, the one of the key issues that I'm currently trying to sort of figure out is basically there's an inconsistency in the data, in the sense that if you picture trying to liken a 3D object to a 2D object, the 2D object tends to be more simple. It's flat, and you can see everything, and everything is on the same level. Whereas a 3D object, you've got angles, and you've got things that are sort of further away from the camera and things that are closer to the camera on the same thing. So like the tiger, some of the stripes may be stretched or shrunk depending on how it's sat or standing and all that sort of thing. And the issue is trying to process the data so that it's a consistent structure going into the algorithm. Yeah. So basically, there's a tool called Extract Compare that the Wildlife Institute in India have already using, called Extract Compare. Basically, it wraps around the live tigers to be able to extract and flatten their stripe pattern. But this is quite a manual process, so I've been looking at possible alternatives, whether it be automating Extract Compare or using a similar algorithm in order to prepare our data for use in the AI. The main problem, in my opinion, is getting the data in as clean and as strong a state as possible, so that when we train the AI, future researchers, people who want to use this tool, don't have to worry about having their own data being clean. Because that's it's a complicated thing to work with. They want to just be able to upload, click scan, and get some results
without having to go through an enormous rigmarole to get the final image sorted out in such a way that it can understand what it's looking at.
Yes, exactly. Yeah.
So when it's actually up and running, what will be the practical value of this Stripes database?
Okay. So the idea is that on full completion, the user, like I just said, the user should be able to submit an image with no prior processing, and the application of it will be that it will confidently be able to answer whether the tiger has been seen before, and if it hasn't been seen before, and then obviously if it has been seen before, whether it matches to any of the images in the database. So if it hasn't been seen before, the image will be added to the database. If it has been seen before, it will also be added to the database, but they'll also be giving a prediction on which tigers it matches. Now, the idea of this is that if you know that this tiger has been seen before, and let's just say in this instance, this is a tiger skin that we've uploaded, and it matches some live tiger images. If it was previously unknown that this tiger had been killed or poached or trafficked, then this gives investigators the heads up, the knowledge that they shouldn't be looking for the tiger anymore. The tiger has, unfortunately been killed. But this would also allow them to be able to figure out when was it last seen, where did it end up, and that means they have a window for when it was trafficked, the routes that it took. So if it went from, say, India to Thailand, they know that it would have to be trafficked across those borders. So the idea is it should help with tracking the tigers, getting on top of the poachers and the traffickers and how they are moving the tiger skins around, and hopefully be able to get ahead of it.
And I presume, as well as identifying tigers that were once in the wild and have now been seized as skins somewhere, the same process applies to tigers that are being held in captive facilities in Asia and China. Yes. Where we can say, well, okay, that one was registered from a photograph by visitors 2 years ago, and yet here's the skin showing up in the marketplace. So clearly these places aren't necessarily the conservation hubs they present themselves as sometimes.
Yes, exactly. And this would be in an effort to obviously combat corruption and illegal trading as well. So it's not necessarily just with butchered tigers, but with live tigers as well. Any sort of movement that is unnatural, or rather, if there's any lack of sighting for a while, and then something is submitted and it's tracked, then that gets people the heads up to know what's going on with these individual tigers.
Excellent. And do you anticipate there will be any other practical applications for the technology that you're helping to develop for this project, beyond looking for tigers?
I certainly hope so. As always, all
It's much work, yeah.
So it's got some really interesting implications, actually. There's plenty of other animals, for example, that have distinctive markings. So zebras are a very, very similar sort of problem. But I believe that animals such as whales, other aquarian animals, they can have distinctive markings as well. And the idea is that this tool, you couldn't just upload an image of I don't know, a zebra or a whale or anything like that to this tool and then get a match, because it wouldn't be linked to the right database and it wouldn't have been trained on this data. And one thing about AI is if it's never seen a certain kind of data before, it's unlikely to be able to understand it very well. But the idea is that when the technology itself is developed, it won't really matter whether or not it's a tiger, or if it's a whale, or if it's a house cat, or if it's a dog, or whatever. It should be able to be trained on new data. So if we had another data set I'm just going to stick with whales here. If we had another data set with whales, with thousands of whale images, and we know the identity of a lot of them, and we can run all the training that we're going to be doing with this on tigers again, then theoretically we should be able to apply exactly the same principles and get the same sort of output and therefore practical application with other animals as we do with tigers. So whilst we're starting with tigers, provided the tool is fully completed, we should be able to use it for more than just that.
Fantastic work. And finally, what for you has been the most enjoyable aspect of working on this Stripe pattern database project?
Frankly, it's working with the people at EIA. Everyone's so dedicated.
That's the right answer.
Well, I'm not just saying it. It's been a total pleasure. But if we're going to talk about specifically me, I suppose it would be getting to apply my technical skills to a true and real meaningful project. I applied for this project specifically because it was, for conservation purposes. And after looking into EIA, it seemed like I could potentially do some good with some people who really want to do some good. I'm just grateful for the opportunity to potentially help with conservation of wildlife. And with my work previously, I've not got to work on anything else that has a practical application in this sort of context. So that's the thing I've enjoyed the most.
Oh, fantastic. Well, best of luck with the project. And maybe you'll come back and when it's nearing completion and give us an idea of how it's going and what's next.
Yeah, absolutely.
Excellent stuff. Well, Shaun, thank you very much for joining us today. It's been a pleasure to chat to you, and thanks for taking the patience to explain more technical stuff to the technically illiterate like myself.
My pleasure.
Now, if you've enjoyed listening to this podcast, please watch this space for future episodes, and do check out our website at eia-international.org to find out more about our work. Thanks for joining us, and wherever you are, stay safe out there.